Trapezoidal rule, and I'll just give you a brief kind of review on it. So assume you have some sort of a curve here that you're trying to find the area of. The way it works is that you draw a trapezoid instead of a rectangle. So you connect like these two endpoints, and then the next one might connect down here. The next one might connect there.
Okay.
And so on. And it's a better fit than the other ones. If you recall, delta x was b minus a over n for left and right sums. It's the same here. But when you actually do the formula, I use delta x, I guess your instructor uses h here. The difference is, so with LRAM, RRAM, MRAM, it's h times all this stuff. But for trapezoid, which sometimes is written like this, trap is h over 2. And then kind of some similar stuff inside here. So
Okay.
that's just something to keep in mind here. So let's pick a pretty basic one here. Let's go, let's say f of x equals x cubed, and we're going to go from, we got to be nicer. Let's go from 0 to 8. Okay. And we'll do n equals 4 rectangles. Okay, so the first step is to find h. H is b minus a over n.
So 8 over 4, so 2.
Yep, equals 8 minus 0 over 2, 4, which is 2. Okay, then the second thing is to start your formula here. So the main difference of the trapezoid and the other formulas is that you use the endpoint once, but then the interior points you use twice. And you'll see that in the formula. It's better just to do an example here. So it's let's see, it's 2 over 2 times, and then it would be f of 0, that's your left endpoint, plus 2 times f of 2, and this is delta x, or h, this is your h to go from this one to the next one.
Okay.
Plus 2 times f of 4, so it's another h.
And then 6.
Yep, 2 times f of x, 6, but then when you get to the end, it's just f of 8. So
Right.
it's almost easier to describe in words, but still a little awkward. It's 2 times the interior points, but the endpoints are just the
Right.
the ones that you don't have. Yeah. So this is your t equals 1. So it's 0 cubed plus 2 times 2 cubed plus 2 times 4 cubed plus 2 times 6 cubed plus 8 cubed. And so we needed the numbers here. This is like 2 to the 4th, so that's 16. 4 cubed is 64, so 128. 6 cubed is 216 times 2, so 216, 432, I guess. And then 8 cubed is 512. And then you would just add all these up and get whatever you get for that. Now you could do it with a table. Table is pretty common. Maybe we should do one example like that, if you would like.
Sure.
And that's actually what you see on the AP, is the trapezoid rule on the table. So let's say I give you time and I give you velocities of something. And so like, let's say at time 0, it's let's say it's 40. Time 2, it's 45. Time 4, it's 60. Time 6, it's 70, and then 8, it's 80. Okay, so we can do the trapezoidal rule for this also.
Okay.
And they don't, we'll get into this with the AP, but like these don't have to be the same width, but they just happen to be. So your h is 2 because that's the width between these.
Okay.
It gets more complicated if it's not, but
yeah, I was gonna say, what if it's not?
What if it's not? Well, that's a different problem.
Okay.
Trapezoidal rule is 2 over 2. It's always over 2. that's the key thing to remember there. And then it's, it would be like V of 0 plus 2 times V of 45 plus 2 times V of, I'm sorry, I got the wrong number there, V of 4. V of 4, 2 times V of 6 plus V of 8. And so V of 0 is this first column. So it's 40 plus 2 times 45 plus 2 times 60. Did I miss one? I missed 2. Wow, that's terrible. I wrote it there. Okay, so that needs to go there. And we need to move this over to get plus 2 times V of 2. Okay, so now it's kind of correct. So V of 2 is 45, 2 times 60, 2 times 70, plus 2 times 70, plus 80. So again, that endpoint is just used one time. It has to do with the way that these trapezoids overlap with each other, like you double use it, and then there's this division by 2 at the end.
Okay.
Which isn't important, but you do have to know the formula for sure. So you add these up, and you get a number.
So 40, 160. Yeah, 470.
Okay, now this is important. Let's just say this was in minutes. No, that wouldn't be reasonable. They wouldn't do that. It would be in seconds, and velocity would be in like in meters per second. The area it would be in meters of this, and you might actually get a problem like that. So that's why that's worth bringing up. Like the units do matter here. It's like taking a physics class or something like that. So if they give you a table like with time and like, water going out of a pool.
What about for the one that had a graph?
So no, because this one just has a function. But if they told you like, oh, this is I don't know, this is like, I guess time's the most common one, but it's like, and this is I don't know, exports per time, then it would have units at the end. It would be the exports.
Okay.
Or whatever it is. And you get dinged on that if you're not careful. It doesn't seem from those slides or whiteboard pictures that you sent me that that's going to be emphasized. But it's worth doing. Okay. Should we go to the whiteboard? Do you want us to work on other stuff? What do you say?
Do you think, is it too complicated if they're different widths?
It's out of scope for this. Like you wouldn't see it yet.
Okay.
So I would say no.
So then let's just go to the whiteboards.
And yeah, okay. So all right. So there's a number of problems here that I guess they're all definite integrals. Is the quiz on Monday or test on Monday?
It's tomorrow, but I'm not taking it till Thursday because I'm going to Phoenix tomorrow. So Thursday.
Okay. All right. So let's just go from 1 to 2. X squared plus let's do a minus here. X squared minus 4 dx. Okay, so this is like one we've done. What do you see here? Like, how would you tackle this problem?
We could do the
So just to kind of help here, I guess what I'm asking is like, do you want to break this apart, which is fine, it works. do you need to do that, or can you just find the antiderivative right here?
Oh, well, the antiderivative, so it's what, 2, okay. 2x cubed, no, x cubed over
Over 3.
3 minus 4x.
Yep. Evaluated from 1 to 2.
And then, so if you broke it up, you'd like draw the 4 1.
Well, you do the same thing. It's just like there's a point where you don't you get comfortable with just doing it as is.
Oh, can't you draw that second one though too?
Sure. Yeah, sure.
Okay.
That's a technique you only use until you learn the rules, and then you never do it again for
I
the
see.
most part.
Okay, so then you evaluate it. So then it's 4. So 2 cubed over 3 minus 4 times 2, all minus 1 cubed over 3 minus 4 times 1. So that's 8 cubed minus 8 minus 1/3 minus 4. 7/3 minus 4. And then to make a common denominator, so it's 4 minus 3, 20 minus. Wait, how did you?
We got the same answer. I heard 7/3 minus 4.
Yeah, but then
Yeah.
how did you get my negative 5/3?
Well, you said it's 12/3, and you just subtract. So it's 7/3 minus 12/3.
Oh wait, okay, wait, that's what I did. So you just do minus 4. 7/3 minus. Okay.
So what does it mean if the area is negative? So this is the function. This is x squared minus 4 from 0 to 2. And we only wanted it from 1 to 2. So this is the area you just found.
Okay.
So if it's negative, as it is here, that means it's below.
Oh, below x-axis.
Below the x-axis, yeah. So if it asks for like a geometric interpretation, or if you see the word interpretation or interpret, that's what they're looking for.
Okay.
It's something like that where you could be there. So is that okay? Is that clear?
Yeah.
All right, so let's do another one. Let's go the integral from 1 to e square root of x minus 1 dx.
E1. What's the antiderivative? How do you antiderivative of square root? Oh wait, so it's
You have to rewrite it.
Yeah, it was x to the 1/2.
Yes.
So then that is.
So remember, you're
adding 1 to 1/2, right?
Yeah. You add 1 to whatever the exponent is.
So then that's
over that, and it works unless n is negative 1.
2. So x to the 3 over 2 over 3 over 2.
Yes.
Okay. Minus 1x.
Okay.
At e and 1. And then you do, so e to 3 over 2 over 3 over 2 minus e minus 1 to 3 over 2 minus 1.
So this 2/3, you gotta handle, I would handle it right away. Like I would bring it out in front of this one.
Okay, so 2/3 e to the 3/2 minus e. 2/3. What happens to the, oh, 1 to the 2/3 is, or 1 to the 3/2 is just 1. So
Yep.
then I
Yep.
just replace it -1. Okay, I see. So then you do
So inside parentheses, this is -1/3. And then the negative goes with it to make 1/3.
1/3 2 3 e minus or plus 1/3. So then I don't really know what else you can do.
That's it. This is their final answer.
Oh,
If you can see that there, it's you have to get more comfortable with the idea that the answers aren't nice. They're not compact. They sometimes are lengthy.
okay.
So is that okay? Make you
Yeah.
comfortable with that? All right. So now let's do another one here. Let's say it's the integral of I'll get to that in a moment. Let's go with x squared minus x cubed all over x to the 5th from 0. Nope, we can't do that. From 1 to 2 dx.
Okay. It's x cubed over x. So okay, so to do the antiderivative for all of this, right?
There's an important rewrite step, and that's what your instructor I think is trying to show you in one of these problems. So you don't know how to do this as is, like, and I don't either, by the way. Like you have to like make a change, which is to divide and divide. So x squared over x to the 5th minus x cubed over x to the 5th.
Write it as 2 set. Okay.
Yes, yes. And then you have to actually like do something with it. So it's like 1 over x cubed minus 1 over x squared. But we still haven't done the calculus yet. That's coming.
Wait, so you just, oh, you did 3 or 5 minus 3. Okay.
Yes. So x to the n over x to the m is x to the n minus m.
1 over x squared.
And we still, still have not evaluated the integral, found the antiderivative.
So it's, okay, so the x to the, wait, that's confusing because now there's a 1 on top. So it's,
So I would rewrite it like this, where you're using negative exponents.
so much rewrite. Okay.
Yes.
So then it's x to the, wait, -3 plus 1, so -2 over -2
Yes.
minus x to the -1 over -1.
Yep.
At 2 and 1.
So before you go much further, I would recommend rewriting this. Do you see how this becomes positive here on the right?
Yeah.
So I would write, and then it's x to the -1. So that's 1 over x. I'm rewriting it here. You can change the order.
Okay.
This one over here is negative. The 2 is on the bottom. And then x to the -2 goes down here.
Oh my God, this is so. Oh.
So it's another rewrite, but it's in the effort of like, or in the spirit of like, let's make the evaluation of this easier, hopefully.
All right, so then you do 1 over 2 minus 1 over 2 times 2 squared minus 1 over 1, which is 1 minus 1. Okay, so So then you do 1/2 minus 1/2 times 4, so 8 minus 1 plus 1/2. So then that is so then you make like all of the denominators 8 and then add them all together.
I would, you could, yeah, you can do that, but like some of these combine like nice, like those combined, that's 1. And then this gives you another one, so that's 2. So it's really 2 minus 1/8.
Okay.
And then that's, and then you can do it at that point, but you're just looking for more ways to make this fast.
That's 16. Okay. 8, so 15/8, yeah. Okay. It's a lot of steps.
Yeah. All right. So kind of a variation on the same problem would be integral x to the 7th plus x to the 8th over x cubed from 0 to e squared dx. And remember, e is just a number. E is, 2.7 something. So it's not a variable.
Okay.
But this too has a rewrite step. Like you have to manipulate it before you can start.
All right. So, oops.
I'm going to step away for 10 seconds, but I'll be right back. If it's not clear from the previous problem, you want to divide both of these.
Yes, I'm already there. And then that's E. Don't you get 1/x to the 4th though when you do?
It would be if the bigger power was on the
okay.
bottom. Yeah.
Okay, so it's just x to the 4th. Why can't you just oh, you have to do the antiderivatives, I see. X to the 5th over 5 plus x to the 6th over 6, and then that's, you can't just evaluate it like that.
Like what?
X to the 5th over 5 plus x to the 6 over 6. So
No. Well, yeah, you can. This is just another way to write it with the coefficients out in front.
Oh, I see. Okay. So then it's e to the 5th minus over 5, e to the 6th. So then, what do you do with the e's?
So you got to remember yet another exponent rule. If you can't tell, that's what's happening here. So when what's an exponent to exponent, you multiply. So it's a review of all those exponent rules that you've seen in the past.
Okay.
So it's
So
1/5
e to the 10th over 5 plus e to the 12th over 6. And then do you make a common denominator and add them, or
No, this is done.
can I write it like e to the 10th over 5 plus e to the
Yeah.
12th over 6, or I have to write it?
Yes, yes,
Okay.
yes, that's perfect.
Okay.
Okay, so after kind of like exponents, the other thing that you might see is a rewrite based on factoring. And all this is like, it's an effort to, well, actually, there's one more example we should do before we do this. Okay, so let's say I wanted you to find the integral of x squared times 4x minus 7x cubed dx from 0 to 1.
Okay, so
So the rewrite here, and you sort of have to be told this, is that you need to distribute first.
all right, so
And if there is like a number in front or a negative, it too distributes. So
4x cubed minus 7x fifth.
yes,
Do the antiderivatives of those.
yes.
So that's more complicated because now there's a number out in front.
Yes, slightly. Yeah.
What's x to get the 4? Is it just x to the 4th?
Yes.
Oh, okay. Minus x to the, that one's how do you do the 7x to the 5th?
So okay, so like the short of it is you add one to the exponent, right? Like 5
Yeah.
goes to 6, and then you divide by the new exponent, and the 7 just comes with it.
Oh, okay. So
Okay, so we should do some more like this because this should be faster than it is now, because I know you're just learning it, but like you don't want to write +1 it will slow you down here eventually.
okay.
It's like do you then write 1 to the 4th? Well, no, you know that 1 to the 4th is 1.
Right.
You could write it. Nothing wrong with writing it. 1 to the 6th is 1, so it's minus 7/6 minus 0 to any power is 0.
-1/6.
Yes. Okay, so I noticed, and you mentioned this here, so let's just do one that's a little bit, let's not even worry about the limits here. Let's say it's 3x minus 1/2 x squared plus 5x cubed minus 10x to the 4th dx here. So let's just get comfortable with like this idea that you're going to add 1 to the exponent. So like this first one here.
X squared.
Yeah, it's x squared over 2, but it's 3 over 2. And I don't care if it's underneath, if it's all underneath, that doesn't matter here. This next one is x cubed over 3, but there's a 1/2, so that 2 on the bottom goes with that 3, so it becomes 1/6.
Okay, so 1/6 x to the 3rd. Then 5 or x to the 4th over 5. No, over 6. So 5/6 x.
No, you're adding 1 to the 3 See how this 3 goes to 4? Yeah.
So over 4, so 5/4.
Right. And then the last one is one more you actually can simplify. It's x to the 5th over 5. but there's a 10. So it's 10 over
2
5.
x to the 5th.
Yeah, which just becomes 2.
Okay.
All right, so now I'll just do a couple more variations of this because this is important to be able to do. Let's go integral 9 square root of x plus 4 over square root of x minus 6x to the 5th dx. Let's just do this one.
Okay, so that is 9x to the 1/2 plus 4 over x to the 1/2 minus 6x to the 5th. So then that's
This one the middle one I would also further rewrite to bring that up.
4x to the -1.
Yeah, negative 1/2, yeah.
Okay, minus 6x to the 5th. So then x to the 3 has 9. Wait, so it's 9 over 3/2.
Right now, when you bring this up, do you remember what happens? How this changes in the bottom?
Flips like 2/3.
2/3. So it really becomes 9 times 2/3 x to the 3/2. And that could be helpful here because you're multiplying these. You might be able to actually simplify them right away.
And then it's x to the, wait, so -1/2 plus 1. That's 2. 1, just 1/2 over 1/2.
But again, like if you,
times 2.
Yeah.
X to the 1/2, so 8 to x to the 1/2.
Right, perfect.
And then we got 6. X to the 6 over 6, so it's just x to the 6, right?
Very good. Yep.
Okay, and then let me rewrite this. It's all over the place. Plus 8x. All right, so then you do cancel the 3's. 6x to the 3/2 plus. So 6, and then you just leave it like that?
Yeah, that's it. Like you're normally gonna have numbers here, but we're not emphasizing that. We're trying to just be like, okay, how do we evaluate these?
Okay.
Okay, so let me show you a couple of weird ones that you probably won't see, but if you don't see them, if you see them now and then you see them on the quiz, you have a chance. So let's say I wanted you to find the integral. We put numbers here if we want. Let's say it's x to the e plus e to the x. We'll just start with this one. Okay, so this looks really weird, right?
Mm-hmm.
E is an exponent though. Like it's a number. It's not a nice number, but it's a number. So the rule is you add 1. See how I'm adding 1 to it?
Yeah.
Over e plus 1.
Right.
Is that okay?
Yeah.
So that's this first one. Plus the exponent here is 1. So it's x squared e over 2 because the e comes down and the 2 comes from the exponent.
I did that. Wait, so. Okay, yeah. But isn't that just what we've been doing?
Yes, but like they look different. Okay. And then we got to evaluate it, which could be a little bit more complicated, but what is 1 to any power?
Whatever the like number is.
It's the number. It's always 1.
Oh, 1 to any power. Yes.
Yes.
1.
So this becomes 1 over e plus 1
Okay.
plus e over 2, because 1 to any power is 1.
Okay. There's nothing for the zeros.
Right. It's minus 0. Okay, great. So here's another one you might see. Integral from 0 to 1, x to the pi plus pi dx.
So it's x to the pi plus 1
Yes, over
pi plus 1
okay
plus pi, plus, that's pi to the 1, so pi squared.
Is pi the variable though?
No.
So let's say it was like 4 here. What would you write?
You would write 4x to the.
You'd write 4x, right? But since it's pi, you write pi x.
Pi x? Oh, yes, okay. And then do that from 1 to 0. So then it's
Yes.
1, which is just, so then that's 1 over pi plus 1 plus pi. Yeah.
Yep, that's it. And you could make a common denominator, but like that's probably not going to emphasize. So just, I mean, these are exceptions, and let's leave it at that because that's not really what your instructor's emphasizing here. Okay, so there's I saw a problem on your whiteboard there. It was like 0 to x t squared minus 3t plus 1 dt.
There was also the ones that like had, I think it was the second picture or whatever, and it was like the ones where he gives you like 3 functions.
Yes.
You know?
Yes.
Okay.
Yeah. So this one we got. I'm concerned that like, and this is fine as is, but there's also kind of like a potentially related question that I want to do. So this one on the left is find the antiderivative. Okay, and then evaluate it from 0 to x.
Okay.
So that's 1/3 x cubed minus 3/2 x squared plus x minus 0.
Yes.
Okay. Now on the right, I'm going to write something really similar. Okay, but it's the fundamental theorem of calculus part something. I don't know which one. It's going to say like f equals this, and it's going to say what is df dt, I think we'll probably say. And what this one is you put x in to your variables. Remember us doing that?
I think so.
And then you multiply by the derivative of whatever function you have up here.
Wait, you multiply by the derivative of
whatever this is up here, which is just 1 in this case.
Okay.
But they're 2 separate questions, and maybe in like through like throwing them up on the whiteboard real quick, your instructor didn't clarify that, hey, there is a difference. Like on the left, you just do it like we've been doing the last 42 minutes. Like you just do antiderivatives and you evaluate it and you're happy. On the right though is the like fundamental theorem of calculus. I think it's part 2. And it will literally say this, like it will have this notation, or the notation will be in front of the integral.
Okay.
And if it's unclear, just go back and review that previous set of notes. But do you visually see the difference between these two? Like, they're not the same problem, even though they kind of look the same.
So like, what is the, like, what would the one on the left be like asking you to find? Like,
It would literally appear like this. Just like if I go scroll back up, it just starts out like this.
then it's just like find the integral or whatever.
Yeah, but the one on the right, here's how the one on the right could be written. Let me do it another way here. It could be written, what is d dt integral 0 to x t squared minus 3t plus 1 dt.
Okay.
That's how it probably would appear. And the mistake is, well, there's a lot of, I mean, there's not a mistake, but like you gotta be careful that you know how to do it.
Right.
Okay, so let's do some of those whiteboard problems that are the, like, here's 3 integrals. Let's see if I can replicate those or just
You
use
can
them.
do those ones too, because I haven't done those.
Okay. All right. Zoom out. No, wrong way. No. It's getting worse. Okay. All right, I got it snipped in here finally. Sorry for the delay on that. So they give you 0 to 2 f of x dx is 5, 2 to 5 f of x dx is minus 7, and then a totally different function from 0 to 5 is 10.
Okay.
And that's how it starts here. So then the instructor asks integral 0 to 5 f of x dx. And before you do this, because the answer is just adding these two together, do you know if your instructor wants you to actually write out, like, show work for these, where you have to write out that it's breaking it?
No, I don't think you have to do that.
Okay, you could just say 5 minus.
Plus, yeah, exactly.
5 minus 7 minus 2. Yeah. Now from earlier, do you recall what it means when the area is negative?
Wait, isn't it 5? Oh, it's 5 plus negative 7. I see.
Yeah.
Okay.
So from earlier, do you recall what it means when the area is negative?
Under the x-axis.
Yes, more of it's under than below is maybe more generally. So then the next question here is the integral from 0 to 5, 3 f of x plus 2 g of x dx. And you can reuse your answer from the previous problem.
3 times negative 2 plus, and then that one is 2 times 10. So then that's negative 6 plus 20, and that's 14. Right?
Yes.
Okay.
Okay, so the next one we should do here, which is not on here, but let's just do it. It's the integral g of x from 0 to 5 plus 2 dx.
Okay, so it's just 10 plus 2, so 12.
Well, okay. So this is the integral from 0 to 5 2 dx. Remember you were asking me earlier, like, oh, can't you draw that? In this case, you have to.
Gotcha.
So it's all this, which is.
So it's, oh, but can't you do isn't it just like the 5 minus 0 times 2?
Yes, but recall what you're actually doing here is 5 minus 0 gives you the base, and the 2 is the height.
Right, so it's 10 minus 10.
10 plus 10, there's a plus here.
Plus 10, so 20.
Okay. All right, so let me grab this, and we've got time for some more problems. Here.
Is it to draw it? You just do like a line at 2, right?
Yeah.
5. And then, okay.
Yeah. Okay. So like another one here would be, what is the integral from 0 to 2 f of x plus x dx.
F of x plus x, okay. So 0 to 2, that's 5 plus how do you do if it's just x though? It's not a number. Like
Right. So you could, remember, we did a bunch of these. You could use your power rule, or you could draw it. And I would use your power rule, like x squared over 2. That stuff still applies here.
wait, isn't that the antiderivative?
Yes. And that's what this is asking for.
I see. Okay.
So antiderivative, area under the curve, integral, they're all the same.
And power rule.
Power rule is like how you find, it's like a subset of one of these, but yeah.
2 squared over 2 minus 0. So then that's 4 over 2. So 2, 5 plus 2 is 7.
Okay. Now see we'll do the last one here that's on the sheet or on the whiteboard here. It is the most confusing, but your instructor was kind enough to provide limits that were reasonable here. So it does work. Okay, so what's over here on the right, this right here, this f of x minus 2 is a right shift of 2.
Right. Okay.
Okay, so to back this off, you have to undo it. That's undoing it, but then the limits change. 7 minus 2, 2 minus 2 dx.
So you can just get rid of the 2
if you change the limits, because you're shifted, because the function was shifted.
Oh.
And like you have to see, like you have, it has to turn back into something you can do.
Right.
So this has to turn back into something that you have given. Otherwise, you can't do the problem.
Okay, so then that's 0 to 5 f of x dx.
Right.
So then that is just the 5. Wait, 5 plus. So that's the negative.
It's just 5. I'm sorry, 5 minus 7, negative 2.
So
Yeah. Yeah. So if you see any shifts, you shift the bounds and you get back to one that you already have.
Okay.
If you need help again before your exam, I'll be available, and I'll send
I'll
you
probably schedule some more before Thursday too.
Okay, sounds good. I'll send you the notes here shortly. Thanks so much, and I'll see you next time.
Thank you. Bye.
Have a great day. Bye now.